Think about the last meal you ate. Whatever it was, whenever it was. The moment you finished it, a clock started running inside your body. Every hour since then, changes have been happening, metabolically, hormonally, and at a cellular level. Most people think fasting is a choice, but your body has been fasting since birth. Every night while you sleep, you fast. Every time you skip a meal, the sequence begins. Today, let's explore this sequence, hour by hour, stage by stage. Discover what your body is doing as fasting progresses. What changes at hour 4? What about hour 12? What happens at hour 16? The science reveals fascinating benefits and limits. This isn't a fasting guide, it's a biology lesson. Start the clock. The moment you take your last bite, your body enters the fed state. This state lasts roughly 2 to 4 hours. During this time, your digestive system is breaking down food. Blood glucose levels are rising. In response, your pancreas releases insulin. It acts like a key, unlocking cells and allowing them to absorb glucose for energy. While insulin is high, your body is in storage mode. It uses energy from your food in banks, the excess as glycogen, stored glucose in your liver and muscles. Any extra energy is converted to fat. Here's the key idea. When insulin is elevated, your body isn't burning stored fat. You can only burn fat when insulin is low. Think of liver glycogen as a battery. It holds about 100 grams of glucose, 400 to 500 calories of energy. Muscles store more. Fasting's early stages are about running down that battery. By 4 to 8 hours after eating, digestion is mostly complete. Blood glucose returns toward baseline, and insulin is falling. A counter hormone called glucagon begins to rise. Glucagon and insulin are opposites. When one rises, the other falls. As glucagon rises, it signals the liver to release stored glucose back into the bloodstream. The liver starts breaking down its glycogen reserves, drawing down that battery. In this phase, most people feel normal. If dinner was at 7 p.m., you might be in this zone by bedtime. Your body is smoothly moving from fed to fasted states, just like it has done many times before. When glycogen stores get low, usually between 10 and 14 hours of fasting, something significant begins. This is the magic window, between hours 8 and 12. Your body starts a remarkable metabolic shift. As liver glycogen nears depletion, your body finds more fuel sources. Gluconeogenesis kicks in, manufacturing new glucose from non-carb sources. At the same time, it breaks down fat, releasing fatty acids into the bloodstream. The liver converts these fatty acids into ketone bodies, an alternative fuel source for your brain and body. Ketone production begins to rise modestly, marking a shift from glucose to fat as the primary fuel. Most people reach this phase nightly during sleep. If you eat dinner at 7 p.m. and wake at 7 a.m., you're 12 hours fasted. You've been running down glycogen and starting the metabolic switch without effort. This leads to the 16-8 protocol, fasting for 16 hours and eating for 8. By hour 16, especially if active, liver glycogen is low. Your body runs mainly on fat. Ketone levels rise, and insulin is at its daily low point. Insulin sensitivity improves here, benefiting blood sugar regulation. Many feel mental clarity at this point. Ketones provide stable energy, reducing dips and brain fog. However, here's the reality. A February 2026 study showed time-restricted eating without calorie reduction offers no metabolic benefits. The benefits from 16.8 fasting mostly come from calorie reduction. When you restrict eating windows, you naturally eat less. Fewer opportunities to eat mean easier metabolic improvements. But if you fast for 16 hours and then binge, metabolic perks fade. Next comes autophagy, between 16 to 24 hours of fasting. This exciting process was awarded the Nobel Prize in 2016. Under nutrient stress, cells begin recycling damaged components. Think of it like a cellular spring cleaning. Misfolded proteins and damaged organelles are tagged for recycling. Autophagy enhances cell efficiency, contributing to longevity and immune function. Studies show fasting elevates autophagy markers, but much research is still in animals. Autophagy begins earlier and builds over time, not just after 24 hours of fasting. After 24 hours, fasting enters cautious territory. Deep ketosis and significant autophagy occur. A notable study found 72-hour fasting refreshes the immune system. Old, damaged white blood cells break down, creating new ones through stem cell activation. But fasting longer carries risks like electrolyte imbalances and muscle breakdown. If considering extended fasting, do so under medical supervision. So, what does the science say in 2026? Fasting aids weight loss. Studies consistently show this. But it works primarily by reducing calorie intake. Fasting improves insulin sensitivity and metabolic health. These benefits are significant for obesity. Fasting activates autophagy and cellular repair mechanisms. While possible, it's still unclear if this directly prevents diseases. Fasting isn't a magic tip for metabolism. It doesn't significantly speed it up. Extended fasting even drops metabolic rate temporarily. The summary? Fasting can be a practical tool. It helps manage intake not because of unique biology, but by creating an easier eating structure. Find a pattern that supports your health, fits your life, and is sustainable. Fasting is one of many useful options. Here's the timeline one more time. Hours 0 to 4. Fed state, insulin high, energy from food. Hours 4 to 8. Blood sugar stabilizes, insulin falls, glycogen depletes. Hours 8 to 12. Metabolic shift begins. Fat mobilization starts. Hours 12 to 16. Deep fasting zone. Fat burning accelerates. Hours 16 to 24. Autophagy activates. Cellular cleanup begins. Hours 24 to 72. Extended fasting territory. Immune system effects. Each night, your body moves through these initial stages while you sleep. You've fasted your entire life. Now you know the biology. What question do you have about fasting? Drop it in the comments. The most common questions will become their own video. A like really helps others find this. Subscribe for more science each week.